All right, let's get into it. You know, we spent so much time looking over our shoulders, cosmically speaking. We're always trying to figure out how it all began, right? The Big Bang. But what if we look the other way? What if we ask about the very last moment?
Pretty much all of human history, that question wasn't really for scientists. It was for philosophers, for priests. But now it's one of the hottest, most mind-bending questions in all of physics. We know the beginning was this incredible, fiery bang, but the end? Well, the end could be something way, way different.
And you know, for a while, we thought we had a pretty good, if kind of depressing, answer. It was called heat death, or the Big Freeze. Basically, the idea was the universe would just peter out. It would keep expanding forever, things would get farther and farther apart, stars would burn out one by one, until all that's left is this cold, empty, dark nothingness, a quiet fade to black. But then, the late 90s happened, and everything we thought we knew got turned on its head. See, astronomers were looking at these really distant exploding stars, supernovae, and the expectation was, okay, we're going to see the universe's expansion slowing down, because gravity's pulling everything back in. But what they found was insane. It was the complete opposite. Something out there was hitting the gas pedal, pushing everything apart, and not just pushing it, but accelerating it, faster and faster and faster.
And just like that quiet, boring heat death ending, gone, thrown right out the window. Suddenly, the end of the universe wasn't a gentle fade out. It could be something violent, something sudden, something bizarre. The whole story became this huge cosmic whodunit with a bunch of crazy new possibilities on the table.
So what in the world is this stuff? What's the engine behind this runaway universe? Well, it all boils down to this one thing, a thing that makes up almost 70% of everything, and yet we barely have a clue what it is. We call it dark energy. The easiest way to think about it? It's like cosmic anti-gravity. You've got gravity trying to pull everything together, right? Clump it all up, and then you've got dark energy doing the exact opposite, pushing everything apart. And in this massive universe-sized tug-of-war, well, right now, dark energy is winning, big time. And that's why we're seeing this crazy acceleration.
Okay, so how does this weird stuff decide how everything ends? Well, it all comes down to its strength. Physicists have this number for it they call W. Just think of W as a knob on a cosmic control panel. Now, if that knob is turned to exactly -1, dark energy is constant. It just keeps pushing at the same rate forever. That leads us back to that slow, cold heat death scenario. But what if the knob is turned just a tiny bit further, to a number even less than -1? Then, dark energy becomes something else, something called phantom energy. And this stuff doesn't just push. It gets stronger and stronger over time, leading to a way more violent ending.
And that brings us to our first candidate for the end of everything. A scenario where it's not a fade out, it's a total demolition, where the very fabric of space and time is torn to shreds. This is the Big Rip. So, in the Big Rip, we're dealing with that phantom energy. It's not just a steady push, it's a push that grows. It gets stronger and stronger and stronger over time. At first, it's just pushing galaxies apart, but eventually its power will grow so immense it can overpower everything. All the fundamental forces of nature. And the countdown is just terrifyingly methodical. It would start with distant galaxies just vanishing from our skies. They're pushed away faster than light. Then the force gets strong enough to shred our own galaxy, the Milky Way. A few months before the end, the Earth gets ripped away from the sun, and in the final, awful moments, the force becomes so powerful it overcomes the bonds that hold atoms together. Everything, planets, stars, you, me, we'd all be torn apart into our most basic particles. Poof, gone in an instant.
Okay, so that's a pretty violent way to go. But what if the end isn't about being torn apart? What if it's about being completely rewritten? This next one is, if you can believe it, even weirder, and maybe a little more unsettling.
Yeah, this isn't a threat from expansion or some cosmic force. This one comes from deep down in the quantum realm. It suggests that the bedrock of our reality, the very laws of physics, might not be as permanent as we think.
Okay, hang with me here. The theory goes that the vacuum of our universe, sort of the default energy level of empty space, is only metastable. What does that mean? Imagine a ball sitting in a little dip halfway up a huge mountain. It's stable, right? It's not rolling, but it's not in the most stable place it could be, which is way down at the bottom of the valley. And the really scary part? Our best measurements of things like the Higgs boson particle hint that our universe might be in exactly that kind of pretty stable but not totally stable state, just waiting for a random quantum nudge to push it over the edge.
So how would this play out? Well, somewhere out in the cosmos, a tiny bubble of that true, more stable vacuum could just pop into existence, and this bubble would expand outwards in all directions at the speed of light. You'd never, ever see it coming. Why? Because nothing, not even the light telling you it's on its way, can travel faster than the bubble itself. One moment, everything is normal. The next, it's passed through you. And it doesn't destroy you in a fiery explosion. No, it's weirder. It rewrites you. The fundamental laws of physics themselves would change in an instant.
Physicist Sidney Coleman put it best. He called it the ultimate ecological catastrophe. Because after this happens, it's not just that life as we know it is impossible. It's that chemistry as we know it is impossible. The very rules that let atoms stick together to form, well, anything would be gone. It's hard to imagine a more total and complete end than that. So we've got the big rip, this violent tearing apart, and we've got this instant physics rewrite. For the past 20 years or so, those two, plus the slow big freeze, were basically the top three contenders. But there's been a new twist. Very recently, some new data has brought an old theory, one we thought was dead and buried, back from the grave.
Yeah, check out this quote from physicist Henry Tai from just this year. He says that for 2 decades, everyone just assumed the universe would expand forever. But now, new data is pointing towards the big crunch. After all this time, the idea that the universe might collapse back in on itself is back on the table. So what's this new evidence? Well, big projects like the Dark Energy Survey are getting results that suggest dark energy might not be constant after all. What if it's not a steady force, but something that can actually weaken over time? If that's true, then at some point it could get weak enough that our cosmic tug of war reverses. Gravity would start to win, and it would pull everything back together.
And what would that look like? Basically, the Big Bang in reverse. The universe's expansion would slow down, stop, and then everything would start hurtling back towards a central point. Galaxies would smash into each other, everything would get hotter and denser until the entire cosmos collapses back down into an infinitely tiny, infinitely hot point, a singularity just like the one that started it all.
And here's the kicker. These new studies put a potential timeline on it, and it's shockingly soon, cosmically speaking, maybe as little as 20 billion years from now. Now, I know that sounds like forever to us, but in the life of the universe, that's not that long. The clock could seriously be ticking.
So, where does that leave us? The big rip? A false vacuum decay? A big crunch? The honest answer is, we don't know. We are living in this incredible moment of cosmic uncertainty. We've looked to the end of time and found not one, but 3 totally different, totally plausible ways it could all end.
So let's just lay them out one more time. You've got the big rip, caused by that phantom energy getting stronger and stronger, tearing everything to pieces in maybe 200 billion years. Then you have the false vacuum decay, the total wild card. It's a quantum event that could happen literally at any second, rewriting reality itself. And then there's the comeback kid, the big crunch, where weakening dark energy lets gravity take over and pull it all back together in maybe just 20 billion years. So what's the bottom line here? It's this. Everything hinges on dark energy. Until we figure out exactly what that stuff is and how it behaves, all of these are just possibilities, not predictions. But look, none of these are happening next Tuesday, right? We're talking billions of years, so for now, we get to live with this profound, incredible mystery. And honestly, that mystery is what pushes science to the next big discovery. And that really just leaves us with one last question to chew on. If we know that it all has an end, that every star, every galaxy, maybe even the laws of physics themselves will one day be gone, doesn't that make right now, this one tiny, fleeting moment, just infinitely more valuable?